Okay, so here's a review on truth tables. In the test, we had something that kind of looked like this. I gave you two expressions. And these are not exactly the ones that are test. I'm just making these up, but they're similar. So we have two logic expressions. We have the negation of P and Q, and we have the negation of P and the negation of Q. So there are two expressions, and the question is, are they equivalent to each other? So we fill out the truth tables for each one of these logical expressions. And in the case of the test, and also in the case of the thing you're going to work, I actually give you exactly the right number of spaces. So if you don't use them all, then you're in trouble. So let's just work through them. So the way it works is that okay, back to my description here. So these are the two tables that we'll use for answering the question whether these are equivalent statements. So both of them are, the first two columns are just the two letters. And I just realized that that doesn't have enough, both of those don't have enough rows. So let me pause again, unfortunately. I think I actually made, okay, so now the correct size. So again, the first two columns in these statements that have, we have just two statements. We have P and Q. So it doesn't matter whether the negation's there, it's just the letters. So we have P and Q, two letters, two columns. Then we have this pattern for two statement logic arguments. We fill it out in the following pattern, and the pattern is to get all the possible combinations of trues and falses, and so these are always the same. So we do two trues and two falses for the P column, and we then alternate trues and falses. And what that does is it gives us four combinations: true, 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 false, false, true, false, false. So anytime you see a logic expression that involves just P and Q, you have the first two columns with all the possible combinations of P and Q. Now, the mistake a lot of people made on the test was we had this logic expression with the negation outside the parenthesis. What that means is whatever the result of this logic argument, we have to do the opposite to. So we need a column just for this outside negation. Then we have the logic expression that's inside the parentheses. So we need to use all six columns in this case. Down here, the negations are right next to the letters, and so those we do separately. We can include the negation in there, but if you have a negation outside of parentheses, then you have to do what's inside the parentheses first and then do the negation. So the first step in all of these, the second step after filling out these columns as shown, is you either copy what the letter is, the truth values for the letter, or in the case of a negation, you copy down what the opposite values are. So trues become falses, falses become true. So you can see in the parentheses I have P by itself, so I just copy exactly what's in the P column. And likewise, I copy exactly what's in the Q column. Okay, then we do the operator inside the parentheses. So we're going to compare these two columns, and we're going to use the AND operator. Well, the AND operator says that the only time you get a true result in this column is if both of them are true. So you can see these are both true, so AND's true. If you don't have two trues, you have at least one false or both false, then they're false. So when you have the AND operator, you always end up with more falses than trues. Now, to get this column, we're taking the negation of the result of this. Well, that's the result of this operation is this column. So what happens is this true becomes a false, and this false becomes true, this false becomes true, this false becomes true. So that's my answer. That's the result, is this column. It's the truth values for the negation of what's inside here. Okay, so we do the same thing down here, except we don't have a negation on the outside, we just have a negation on each one of them separately. So instead of copying true, true, false, false from the P column, we do the opposite, which would be false, false, true, true. And then the negation of Q is the opposite of what's in the Q column. So instead of true, false, it's false, true, false, true. Okay, now this is the AND operator again, and the AND operator is true only if they're both true. So you'll notice that the last row has two trues in both locations. So that's true, but all the other ones are false because there's at least one false. So that's the result of this, the result of the thing we look at to see what the truth values are for this logic operation or this. Well, notice they're not the same. False, true, true, true is not the same as false, 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 true. So we would say that these two expressions are not equivalent. If I'd gone and I had, say, used an OR statement instead, then I would have gotten the same as this. So if I'd switched this to OR, so let's just do that just to demonstrate it. This were an OR statement, and that became OR. The OR statement rule is that the only time that it's false is if they're both false. So we'd end up with this result: false, true, 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 false, true, true. So these are equivalent to each other, these two, with the OR statement. But with the AND statement here, they were not equivalent to each other. Okay, so now we're going to move on to another one, and in this case, the logic expression is, and I need to change the thickness of the pen. So that's so that I think I can draw a thinner pen. No, I think if I go here, maybe that's thin. There we go, that's what I'm looking for. That's what I'm talking about. Okay, I keep pushing that on my tablet. Okay, so the logic expression I'm doing here is the negation of P or Q and P or the negation of Q. So it's a little more complicated than the previous one. It still has two letters, P and Q. So when I fill this thing out, the first two columns are just the same as the previous one. We only have two letters, and remember it's 2 to the n. We need 2 to the n, which in this case is, n is 2 letters. So I only need 4 rows to fill out the truth values. I've got the first row as being a header. So I do true, true, false, false, and true, false, true, false. Okay. And now I write the logic expression. Notice none of these negations are outside the parentheses, so I can write the expression as such. So I don't have to use the whole table. I only needed 4 rows for the truth values. Now I go back to the ones that just include either the negation of the letter or the letter. So when I have the negation, I just go to the column that has P in it and I do the opposite. And I go to the next letter, which is Q, so I just copy Q in this case. I copy the truth values that are there. Here I have P, not negation of P, so I do exactly what's in the P column. It's to the left. True, true, false, false. And then finally I have the negation of Q, so I go to the Q column. That's true, false, true, false. So the negation would be false, true, false, true. Okay. Now we do what's in the parentheses on either side. And we're going to come up with a result, and then we're going to compare those. So we have the OR statement. The OR statement is false only if both are false. So this is the only case where they're both false. Here there's one false, but one true, both true, one true, but one false. So for the OR statement, the only one that's false is this one, false, false. Here we have another OR statement. So again, we look for the case where we have two trues. So true, true is true. Actually, let me correct what I just said there. It's an OR statement. So the only one that's false is where they're both false. Otherwise, as long as there's one true in there, we're in good shape. Now what we do is we compare these two columns, because those are the results of these things in the parentheses. And we have an AND statement. So what we look for is two trues. We compare this column with this column. True, true is true. True, false is false, because we have at least one false. We have true, false, which is false. And we have true, true, which is true. So the AND statement is only true if they're both true. So this one, they're both true. This one is both true. But these here are not both true, so it's false. That's the answer that we have. Okay, the last one is where we have three statements. And the expression we're going to have is the negation of the quantity, the negation of P or R, or the negation of R and P. And actually that is not what I want, because I don't have a Q in there, so let me fix that. I need to put a Q. So let's where am I going to do that? Let's just put that there. So I'm going to change it. So this is and Q. Okay, so I've got three letters, P, Q, and R. So the first three columns are all the possible combinations of trues and falses for three statements. So in the previous ones, we had 4 rows that we did the truth values in. In this case, we take 3 letters, which is that number, 2 to the 3rd power is 8. So we're going to need to use 8 of these. The way the pattern works is the first column, this is just a pattern that gives us all the possible combinations. So we do 4 trues and 4 falses. Then we do 2 trues and 2 falses. And when we get to here, we start over again. 2 trues, 2 falses. So you can see, half of these are trues, half are falses. Half of these are trues, half are falses. But they're a different pattern. Likewise, finally here in the last column, we alternate true and false. So we do 1 at a time. So here we did 4 at a time, 2 at a time, 1 at a time. And what that does is it gives us all the possible combinations of trues and falses for these 3 letters. So we have true, 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 we have false, 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 and then we have all the other combinations. So again, when you get a logic statement that has 3 letters, P, Q, and R, you have to have 3 columns at the beginning which follow this pattern. So you either understand the pattern or write the pattern down so that you won't forget it. Okay, then we do the logic expression. So again, this negation is applied to this whole thing. So we have to do this negation by itself. This negation is right next to the letters, so we can put those 2 together, and the parenthesis gets grouped. We have the OR statement, we have the R, again the parenthesis gets stuck in. The parenthesis always gets stuck in, and if the negation is right next to the letter, that also gets grouped in. Okay, so next we have an OR. This parenthesis, the negation, and R all go in the same column. Then we have the AND statement, and then we have the Q and the parentheses. So again, you notice I didn't have to use all the rows or all the columns. I just use the ones that I need to use. So again, we go back to the columns that either have the letters by themselves or the negations of the letters. So we'll just start from the left. Here we have a negation of P, which means I write down the truth values that are in P, except they're exactly the opposite. So here I have 4 trues and 4 falses. So I have 4 falses and 4 trues. Okay, this is the letter R. This is statement R, so I do exactly what's in the R column that I have set up earlier. Okay, what's the next letter we get to here? Negation of R. So I take the opposite truth values. So true, false becomes false, true, and then we just continue the pattern. And then we have Q, so the column Q, which is true, true, false, false, true, true, false, false. Okay. Now, what we're going to do is do what's in the 2 parentheses, because we always do stuff in the parentheses first. Here we have an OR statement. So the only time the OR is false is when they're both false. So we look down here and we see these are the only 2 cases where we have both falses. Every place else has only 1 false or no false. So those all become true. Okay, so that's the result there. We go over here. This is an AND statement. So the only time an AND is true is when they're both true, which happens in these 2 cases. Every other case, there's at least 1 false or both falses. So those become false. That's the rule for the AND statement. Okay, now in the past we would have compared these 2 columns, but we have to take the negation of what's on the left-hand side, so we get the whole left-hand side result. So I take this column, which is the result of what's in the parentheses, and I do the opposite. So everything in this column becomes the opposite truth value. So the true here becomes false, the false here becomes true, true becomes false, false becomes true, and then I've got all these trues, so those all become false. So that's the column that represents the entire left-hand side, and then I compare that with this column, which is everything that's on the right-hand side. So now I look at what the operator is, which is an OR statement, and the OR statement is false only if they're both false. So you're going to want to compare this truth value with this truth value. See, they're both false, so that's false. In that case, they're actually both true. Here we have both false. I write it down. This is true already, so I know that's not going to be. What I'll do is I'll just go down here until I find a false, and then I'll compare that over here. See, that's false. That's false, so I get false. That's false, and that's true, so it's not false. True, false here with false there, that's false. And then false, false, that's false. Okay, so these are the 5 rows where these both are false. In this column for Kirsten's income, and all the other ones are true. And so that's the final thing that I did, and therefore that's where the answer is in that column. Okay, so that's an example of each kind of problem that was on the test and is going to be on the retake. You just have to make sure you understand what this involves. So if you don't understand it, you might watch it again until you do understand it, or come see me or see a tutor or something.